All right. Very good evening, everyone. Uh, so we have waited 4 more minutes. Now it's 4 past 4. So let's start our sessions. In the meantime, people will join in. A very good evening, everyone. Welcome to the 19th episode of Anveshan, that is the Knowledge Byte session. We have been conducting on the first Saturday of every month from 4 to 5 p.m. So, in that series, we bring you yet another exciting topic on emerging technologies, that is 3D printing, or also called additive manufacturing, and its application in steel industry. So it's a very interesting topic, and nothing new to the sale community, because some of our unit has already gone ahead with 3D manufacturing and set up some of the infrastructure in that direction. uh, we have the privilege of having with us the entire team from Adroitech Informations Systems Private Limited, which is the organization that has supported the endeavor at Rourkela Steel Plant. So let me just confirm if Atanu sir has joined the session. Atanu sir, are you in the meeting? Okay, so I'll take the privilege of welcoming all the esteemed chief general managers and executive directors who could take out time to join today's episode, and their young mentors who are assisting them in understanding these emerging technology. Thank you for your continued support in these sessions. Let me welcome the entire team once again from Adroitech Information Systems Private Limited. I have the privilege of welcoming Mr. Vinod Kumar Pandey, who is director at the organization. Along with him, we have team from the organization, Mr. Abhishek Mandal, Mr. Lalit Bajaj, Mr. Vikas Mudgal, and Mr. Manoj Jain. So it gives me immense pleasure to welcome you all in today's forum, and I must thank you for your prompt response in not only accepting our invitation but taking out time to discuss and join, and then formalize today's discussion. So on that note, yes, Atanu sir, are you able to hear me? Okay. All right. So on that note, today we what we have planned is that we will be conducting 1 hour. We have already spent 7 minutes. What we have planned is that we'll have around 40 to 45 minutes of presentations that will be done by the team from Adrotech Solutions, and then we'll have last 10 to 15 minutes of question and answer. But I'm not going to restrict it to that structure of the discussion. If you want to have your discussion or clarification in between the presentation as well, you are most welcome to do. But we have 10 minutes towards the end, and then towards the end we'll have summarization and vote of thanks. So on that note, I would request Mr. Mondal to kindly take forward the discussion.
Yes, and good afternoon, everyone. So it is my really pleasure to be here in this meeting. Although I'd like to thank the entire sales team as well as to Atanu sir, Chandra sir, everyone. So briefing about the company, that Adroitech is a 32 years old company. Yeah, so back in those days, our founder director, Mr. Sarup Chand sir, has keep it a vision to go with this technology, and he has invented Autodex here in India. Later, year by year we have been growing, and for the last almost more than a decade now, we have been into 3D printing. We are not into only into the 3D printing. Also, Adroitech is several other divisions who are directly working with the softwares, designing software, simulation software, robotics, as well as with the AI and ML technologies, and the several other sections as well. So coming back to me, Mr. Vinod Kumar Pandey sir, Mr. Manoj Jain sir, Mr. Lalit Bajaj, and Mr. Vikas Mudgal are in a team that is called 4D Simulations. So 4D Simulations is primarily a team who has been extensively working with all 3D printers. So in our product portfolio, yes, we are working with the leading 3D printing companies all over the world. Naming few as a Stratasys. On the Stratasys, we are dealing with all their thermoplastic solutions. their polyjet solutions, their powder plastic solutions, and their P3 technology. So apart from these thermoplastic solutions of strategies, we are also into metal 3D printer, that is from SLM Germany as well as in the Exact Metal US. And we are also into the DED technology, that is the direct energy deposition, and wherein we have our own developed 3D printer that has been developed with the help of Ministry of Atomic Energy under the guidance of RRCAT Indore. So in this today's presentation, we will be keenly focusing on the sectors that how this particular technology, that is the 3D printing, whether it may be a metal additive manufacturing or it may be a thermoplastic, that is a composite series 3D printer, and the 3D scanners and help out a steel industry in their flipping forward sessions. So now I would like to request you that my Binod sir could say a few words, as well as to Manoj sir to say a few words about their huge experience in this particular field. And later on, we will start the presentation about the metal 3D printing and then the thermoplastic as well as the 3D scanners. So over to you, Binod sir.
Good afternoon, sir. Chandra sir and Tanu sir, to sell India to given the opportunity us to interact with you and your organization. So Abhishek already explained about our company profile. So we are a dedicated working for the engineering solution to provide the best solution to our relationship customers, and to also giving always we are standing behind our customer. So I think we don't have too much time, so our technical team can start the presentation first, and then we'll discuss the question answer session. Thank you sir.
Thank you, Binod sir.
So,
Manoj sir,
whom should I make the presenter?
Okay,
yes,
so just little Vinod, I just say that our journey in additive manufacturing has been great, where we have transformed ourselves from representing the overseas brands to build our own metal 3D printers and the plastic printer brands. We started our journey somewhere in November of 2013. I very clearly remember those dates, and it's really been a fantastic journey. And as you said, the Rourkela steel plant setup, it was completely done up by our team, and since then we are evolving. And currently, though Vinod is taking care of all operations of 4D simulations, I have dedicated myself to build metal additive business, promoting the indigenous technology. So, though today Lalit is going to talk about it, we have taken two indigenously developed technologies for metal 3D printing. One in collaboration with Department of Atomic Energy, with Abhishek has talked about, and another one recently we have gone in with IIT Indore for micro 3D printing to really build micro sensors, micro heaters, and micro level 3D printing. With that, I give it to the technical team because that is more important to talk in this session. And then, of course, me and Vinod will be around to answer any questions later on. So thank you for inviting us for this talk, and we hope it is useful to everyone. Thank you.
yes, Lalit, you can start your presentation. Yes.
Yes, Lalitji, you can share your screen. I have made you presenter.
Hello, am I audible?
Yes, you are
Yes,
audible.
Yes, just a second. Is my screen visible to everyone?
Yes, it's visible.
Yes. So coming to Bfuse Metal, it's a part of Edutech Group. So it is founded in 2023, and it has been incubated at RRCAT Indore, which is our Department of Atomic Energy Associated Research Center. And we majorly focus towards metal 3D printing, MRO, and cladding-based services. It's a DIPP recognized startup. We have driven to provide best-in-class additive manufacturing solutions. Our vision is innovating manufacturing one layer at a time, and our mission is to promote indigenously developed technologies in metal AM as well as additive manufacturing to the global market. And our core philosophy is to have a 3R strategy. That I will explain it on a later stage when during my presentation as well. So we have incubated at RRCAT and we are developing LAMDD with them. This is a letter from RRCAT that we are well supported by the team RRCAT and the facility they have for the material research as well. So according to us, the material research will play a key vital role in development as well as adoption of additive manufacturing in India. So by means of RRCAT, we are able to have that support as well. Coming to the technology. So in the technology, there is a coaxial nozzle, as you can see here, in which the metal powders comes from the side, and from center, a laser beam is coming. So wherever it meets, it forms a melt pool. And this particular nozzle can be mounted on a 3-axis system, can be mounted on a 5-axis system, or an 8-axis robotic system as well for higher depositions as well. This is a small launch video of what of our current system that is installed in RRCAT, our demo system, and this was launched by Dr. Chintan Vaishnav and Dr. V. Narayanan, who is the current chairman of ISRO.
Once again, we would like to highlight the fact that this is indigenously developed metal 3D printer, which is working successfully, and we have completed. Lalit is going to share. So the deposition head has been built in collaboration with RRCAT Indore. We are further working and improving it. So this is an indigenously developed metal 3D printer. So this is the core we want to highlight here. Yeah, Lalit, carry on.
Yes, thank you, sir, for imparting that knowledge. So coming to our capabilities, we are system manufacturer and system enhancements we can provide as well. So we are an OEM. We can provide system manufacturing services as well. A custom system for your specific needs can be designed and can be manufactured for you as well. And whatever enhancement you want in our current system, we can provide it to you as well, such as in the next few slides I will be explaining you that majorly. And then we are our second capability is surface engineering, material support and research, feature add-on and part manufacturing, and the 3R strategy. Our capabilities come into the place where we can have customizable system manufacturing, The current system that we have at RRCAT, installed at RRCAT, is 500. A 5-axis system with a high laser power of 2 kilowatt, 500, 500, 300 mm is a build volume. For for material research, we have designed a new system which is Twister 250, which is a material research engine which has a low operation cost. This is for basically for research centers and for IITs. And for more industrial and robust use cases, we have designed Twister Robo Plus with IRB 4660 kg ABB robot, which can give you a reach of 4 meter by 2 meter by 1 meter, 2 meter in height as well. Recently, we have collaborated with IIT Indore and transferred one more technology to our bucket list, and that is a micro 3D printer, which is majorly used for having developing some mission critical sensors and strain gauges as well.
Here I would like to add, can you go back a slide back, Lalit?
Yes.
On Twister Robo Plus, if you really look at it, we are integrating wire arc additive manufacturing with the laser additive manufacturing. So the bulk deposition and the large deposition at the faster speed, you can do it through wire arc, and the small feature and the fine geometry, you can do it with laser DED process. So here we are integrating two additive manufacturing solutions on one single platform. Carry on, Lalit.
Yes. Thank you. So in system enhancement, we are capable enough for having closed loop control over our systems. Though our current system is able to have melt pool temperature measurements, melt pool width measurements, standoff distance calibration, beam width and height measurement. These are the system enhancement we can have in our system, and its nozzle design is our on. We have indigenously designed our nozzles, so we can have auto variable spot sizes, ID cladding nozzles, and recently we are designing one wire-fed single laser nozzle to have higher deposition with a single laser itself. It would be a one of its kind, and we will file a patent against it as well with RRCAT. Coming to our capabilities in surface engineering, we can provide wear resistance, corrosion resistance, thermal barrier coating, biomedical functionality, oxidation resistance, and erosion resistance to all the steel plants parts that generally get eroded out, corroded out during the operations. We have already tried most of the materials, and few of the case studies I will be showcasing in the next few slides. This is a case study that we did for one of the space organization, in which we have deposited Inconel 718 over a copper nozzle. The good thing about this is that you can see our internal cooling channels there, and that channel thickness is of that wall thickness of those is of 0.8 mm, and we have deposited 5 mm of Inconel 718 over it. So to give it the structural as well as thermal barrier coating as well. This is a project we did for BARC, in which we have basically deposited copper over titanium substrate, and this is a 400 mm dia plate on which we have deposited copper for enhancement of the properties. We are keen into material research as well, and we have basically done various material research projects for majority of IITs and IITs across India, and for some research laboratories as well. This is a copper nickel FGM that we have deposited for BRC. The beauty of the technology, you can see here, there's a 2 layer of copper, 2 layers of nickel. This is how this particular part has been printed, and by any other process, if you want to manufacture this is not particularly possible. These are the current material support that we provide. We have extensively researched on Fe-based alloys, nickel-based alloys, cobalt-based alloys, titanium-based alloys, copper-based alloys. In cobalt-based, we have basically done with L605, Staylite 6, Staylite 12, some super alloys to have very good wear resistance. These are some of the material research we have did with RRCAT. Coming to our third capability, which is feature add-on and part manufacturing. So we have manufactured a hemispherical dome for one of the space organization. This is a 300 dome kind of structure. This is basically a rocket propellant tank in which the hydrogen gas will be stored. A small video of deposition just to give you an idea of how a 5-axis system can be used for having supportless parts in additive manufacturing. This is a capability demonstration. We are approaching many of the firms for this. We have basically deposited thin wall turbine blades, compressor blades in titanium for GT turbine engines and ST turbine engines as well. This is a 90-degree bend that we have deposited for heat exchangers. Basically, if you go with general pipe bending, you find a ovality. This is completely circular from inside, so no flow rate will be changed. This is a feature add-on for an oil and gas industry we did, in which this is a Stay-Lite 6 deposition on copper. So just to enhance the feature, you can have a final feature addition on it. And they have tested it out where we have got the hardness value of 53 HRC, and it is a 99.7% dense part what they have got. The final part is for the casing of the GT turbine engine. They want to add feature on that. This is a T-joint of scenario. If you want to have a T-joint of scenario, this is for a project we did for IG car, in which we have deposited this particular, it is not welded. This particular pipe is deposited over this pipe. So our major capability is MRO, and I think this will help in steel in sale as well, majorly because majority of the parts in steel plants are imported out, or the steel plant itself is a Russian made or any outside made itself. So, and generally the parts got worn out, and we have to import those parts. So the whole supply chain management needs to be happened here. So we have defined a 3R strategy to repair the parts. So we have reverse engineering the geometry. If a part comes to us, we will first reverse engineer the geometry of it. We will reverse engineer the material of it. We will reverse engineer the field condition actually that is working on it, on that particular part. In geometry, we have 3D scanning of the part, profile mapping, scanning strategy optimization. Any fixture design needs to be happened for AM for as well as for machining as well. This is apart from 3D printing what we do. Because there are majorly parts in majority of the MRO units in which they don't know even the material of the part. They just have the part that needs to be developed or that needs to be repaired. Then we will do the material extraction. We do the XRF for powder atomization. We do the phase analysis, microtensile. All material testing is performed on it depending upon the field conditions of the part. And thirdly, we will evaluate the manufacturing process of the part, how that particular part has been manufactured. We will evaluate the hardness across the part, whether any heat treatment is performed on the outer edges or not, case hardening, any kind of scenario has been done on. And then we will evaluate how we will be machining that particular part. Or in some cases, hips can also be provided for having a uniform structures inside the part. And CMM and tomography can also be done. This is a process. So first, material identification will be done. Hardness analysis will be done. Then material procurement. We have a tie-up with an Indian vendor who can supply metal powders to us of majorly any grade. There is a reverse engineering of the geometry. Then
I just want to highlight here, sir. Just 1 minute, Lalit. Here I want to highlight one fact, sir, that we are not bound by any material. Like a lot of printer which are in the market, they tighten you for the material or the equivalent. Actually, we have tried out certain materials which nobody globally even tried manufacturing them, and one of them is EN39B. So we have tied up with one Indian vendor who is the manufacturer of the metal powder, and he helps us in giving us the material of the part or as close to the part where it is actually manufactured. So this is also a very critical element which we have added in our 3R process, where we are able to get the material which is either the same which is in the part or very close to the part. So carry on, Lalit.
Yes. If it's a new material, then we will do the parametric optimization of it, and then on the actual part, we will deposit it out. We do the machining, we do the heat treatment, triple FT, form fit, and functional trials will be done, and it will be given to the field testing for actual in the field conditions how that part performs. These are some of the parts that we did for a load bearing tank. Uh, these are the gears in EN39B, and we have successfully done field trials for these gears. Worldwide, majorly, most of the industries, no one in the world has been printed EN39B. This is a new strategy that we are proposing. Suppose there is a one gear which has been worn out, or one of the teeth got worn out. We will remove that particular teeth, we will deposit that particular teeth, and then do the wire EDM of it. We will machine it out, case harden it, and give it back to the field. This is again a project we do for defense. Basically, this is an oil pump assembly of a tank itself. So the top portion of the assembly, this is a bush, which generally gets worn out only by a 400 micron thickness. We have redeposited it on it, and then machined it out, case hardened it, and given it back to the service. This is a piston for a Bofors gun. This is a project we are doing with in which the top portion is deformed. You can see in this particular picture. We have redeposited and remachined it out and given it back to the service. This is a project we are doing for. We did it for one of the defense laboratory, in which we have basically defined a strategy to fill 100 by 0.2 by 2 depth cracks, which is generally available in most of the industries as well, in dies and molds as well. This is a aero engine part, and we have successfully deposited material. We have derived a strategy. They have provided us a similar simulation plate for it, and we have derived a strategy to repair these kind of cracks. So in this, we have grooved out the crack to a 5 thickness by 2 of depth in a trapezoidal strategy, in a semicircular strategy, and we have tried it. If you do the laser welding, what will be the results for it? And we found out that at the semicircular strategy, we have found the best results, in which our maximum tensile strength is of 917. The actual part has a tensile strength of 896 MPa, and we have basically achieved porosity levels less than 0.5%. The good fact, at 816 degrees Celsius in stress after test, at 179 pressure bar stress, it broke from the substrate, not from the crack that we have deposited. These are some of the other cases that can be useful in your scenario as well. This is a fixture in which one of the portion is got worn out, so we try to reclaim that particular portion. I cannot claim the client for this because it's a NDA. This is a teeth which is deformed for a 1 meter long gear shaft pinion, and we are reclaiming this particular teeth as well. Some of the steel plant case studies. This is a case study we are doing for one of the steel plant, in which we are enhancing the wear and corrosion resistance of the steel rolling mill rollers. We are depositing Steelite 6 over it and tungsten carbide over it. Currently, we are evaluating the material side of it. We have collaborated with IIT Indore for this particular project, IIT Indore and PEC Punjab, Chandigarh as well, for this particular project, so that we came up with a good results for them, and to how to basically have wear and corrosion resistance, how to repair rolling mills, rollers, cold mill rollers for steel plants. This is a shaft bush bearing on which uh, a white metal deposition is done. So just to increase its wear resistance and its lubricating facilities as well. These are some of the case studies for worldwide case studies for some steel plants. So this is uh, stone crushers, uh, crusher rolls, coatings, ball walls coatings, ID claddings. So we have a specific nozzle for ID cladding as well, where you can basically clad inside the material and repair inside the pipe as well. These are some of the use cases of RSP, so Rourkela Steel Plant. So they have also installed one metal additive solution. We have team at and we are completely supporting them for their design and for their manufacturing processes as well. These are some of the parts that they have printed on their machine, and I'm up for any question answers. I think that will be on a later end of the session. Thank you, everyone. Thank you for giving us the time.
So thank you
Yes.
so much, Lalit. Sorry, Chandra sir, please.
Yes, yes. So thank you so much. It was really interesting to see so many use cases coming up, across industry, specifically using metals. Can you set some more light related to the setup that we have in the Rourkela steel plant, how it is operating, and the type of printer that we have there?
Yes. So, sir, am I visible, sir, to the dais?
Yes, you
Yes.
are visible.
Yes.
Yes, sir.
So,
Uh, just a minute, Lalit. Sir, at prior to that, we were dealing with those 3D printers. Back those days when Rourkela Steel Plant has installed the systems there. But now, we're very specific on the technology, and this particular technology is much more developed than the RSP one. So yes, we do. We have supplied that. We have successfully run that. We have successfully did the hand holding to each and every person or maybe the user of Rourkela steel plant. But for the better proposition of the product as well as the technology, my suggestion will always be for a DD technology for any of the steel plants where there is no choice of materials as well as no choice of size. As Lalit rightly said, that the size can be for from a very small tiny parts that we have did for the Vedanta steel. The size of the part is maybe half an inch, and as big as a cold roll mill, which can be meters of length. So for the ideally for any steel plant which comes under the cell or maybe any defense or DRDO organization, currently DD is the most right technology for that. Over to you, Lalit.
I totally agree with what Abhishek sir has already told. I agree that we have provided a different solution at Rourkela Steel Plant. During my visit in Rourkela Steel Plant, I stayed there for 2 months. I realized that their application is far more driven if we go for a metal additive solution. So that's why it really gave us a boost to have this initiative to start our own metal additive solution, because they are struggling with the materials as well. They have only, in that particular technology, there are only 5 materials that we can print. So material limitation was there. So that's why that give me a boost to have our own 3D printer in which we can have, that is not a, which will not act as a black box of five of any number, where we can have a n number of materials, not specific to the availability, but specific to the application that we have.
So I have a very layman type questions that I wanted to ask. So in a steel manufacturing plant, we have so many spares that we deal with. Uh, how do we manage, say we can reverse engineer and do a 3D printing of those spheres if required. uh, how do you deal with is there any chances of IPR rights or violations or anything like that in those cases, or
So,
it's industry practice?
so actually, sir, you have raised a very valid question. But the whole thing is the part which we have currently tried out. Those are the parts people are already doing either through TIG welding or the arc welding and repairing it. Like in your place, I've been to Bhilai steel plant. There, the steel rollers they are doing with submerged arc, repairing it and doing it. So that processes of repair doesn't really violate any IP. And
Okay.
we are not taking any design because design is with them. We are only replicating the material and the geometry. We are not replicating the design engineering per se. So we are more moving towards the application and the use of it rather than design of it. So
Okay.
generally industry is already doing it. It's a well settled practice not only in India, globally. And I have not come across that there have been anybody who has come forward and said it's a patent violation, because as an user you have purchased that equipment and you have all the right to maintain and make that equipment into the working condition. So that's what you are doing, and that's where I don't see any violation of the IP value. And we have also not come across any such scenario where OEM has raised the, at best they say if it is in the warranty, then they may say that your warranty may get void. But currently all the equipments which we have come into play, either the OEM is not existing, or those parts are non-existing, or they are not really giving you, like we have attempted this artillery tank project where OEM supplied the whole gearbox, whereas only 3 or 5 gears are borne out in the whole transmission gearbox. Then they say that instead of spending 50 lakhs, 60 lakhs on whole of the gearbox, if I can repair only those gears and replace them, what is the harm? So as long as our understanding is concerned, sir, this is a practice which is already being done by all the users of these equipments. So we are not really doing, we are only improving the process of doing it. So right now, we are doing through submerged arc or TIG welding, where we are actually not getting in deeper into the substrate. But when we do it, in fact, when we do any of such repairs or the deposition, if you take a cross section at the joint, you will not find it merges completely with the substrate, and it creates an alloy at the substrate. So it gives you the strength, and that's what Dalit showed, that for the aero engine repair, our strength was better than the substrate itself. So we have given more strength, and that comes primarily because of the granular structure which is formed by the additive manufacturing. So that gives more strength than the substrate which has come from the normal practice. So your question is valid, but our answer is this practice is currently in use everywhere globally, and we have not come across anywhere where patent violation has been claimed. Hope I have answered you, sir.
Yes, yes. Thank you, sir. Thank you for such an elaborate and confidence building answer. Let me invite, if we have so many audience who are part of this session, if you have any questions that you would like to ask.
Sir, before that, I think we have a second section of the presentation
Yes.
that is on polymer. So
Oh,
Vikas,
is it? Let's go
so
ahead with that
let's quickly
quickly.
finish that. Let's quickly finish that in that, and then we will take the question answer, sir.
Sure, sure, sure,
Then
sir.
we can move to the question answers.
So, Vikas, please prepare yourself. And, before Vikas would start the presentation, so this technology, what we are proposing now in the thermoplastic series, it's a composite series 3D printer from Stratasys. Now, the use of this composite series 3D printers are basically done to replace any metal to any other thermoplastic part. So Vikas will shortly define that how we actually are doing it, and also he will explain a little bit about the 3D scanning as well as the reverse engineering. Over to you, Vikas.
Hello, good evening, everyone. Is my screen visible to everyone?
Yes, yes, your screen is visible.
Yes, yes.
Yeah. So, as Abhishek sir and Vinod sir and Manoj sir has already informed you that we are part of Adrotech. So, under Adrotech, we have a group which is called 4D Simulation. So, let me talk about Adrotech first. So, we are 34 years old group. So, we are the one who are pioneers into CAD CAM since 1986, and currently we are into 3D printing right now. So if I talk about especially for the 4D simulation, so we have currently every of the technology that is available with the 3D printing. So if you talk about FDM or SLA or SLS or DMLS, or just like Lalit has informed you about DED, so we have every technology that is available in the PAN world. Apart from that, the material that you talk about, we have every of the materials that are available, which include basically polymers, resin, metal, clay, ceramic, cement, everything that you talk about. So let me talk about some a brief about the technologies. So first one is the FDM, or fused deposition modeling. So in this one, what happens is there is a filament which is completely plastic or polymer, thermopolymer, which are basically heated up to a semi-liquid state and extruded on a built platform to get a layer by layer addition, and through which you'll get a completely 3D printed part. Next one is the SLM. So SLM is currently having the metal particles, which is metal powder that is having 15 to 45 microns of particle size, and using a argon or nitrogen gas flow, we start to sinter those particles and to make it completely a single layer, which basically added layers by layers to make a completely 3D printed part. So these are the samples for metal part. Apart from that, we have polyjet technology, which is actually patented by Stratasys. So in this one, we have resin material. What happens is, if you can see in the video as well, we have resin material which basically extracts out from the head. Then we have UV lasers which solidify that liquid material, and it basically get adhesion layer by layer. And the last one, if I talk about, that is the binder jetting, in which we have a binding agent. So the raw material is also a polymer, which is completely nylon. So the binding agent basically bind that polymer, and later on, using high intensity of heat, it basically adds layer by layer. So with the statuses, we have a good portfolio. Currently, which one I will talk about today, that is F370 CR. CR means composite ready. So what is the plus point for statuses? So what we have is multiple materials starting from ABS, ASA for prototyping until high temperature material, which include nylon, nylon plus carbon fiber, or talk about Diran. Then we have easy to use of this machine. So these are basically the technical specification for the machine. If you can see over here. So as you can see, we have a good material range starting from ABS or PLA. Then for tooling, we have Diran. Then for jigs and fixtures, we have ABS CF10 and nylon CF10. Then if you are using the part outdoor, we have ASA material, which is completely ABS, but having UV resistant properties. Then we have for electrical enclosures, we have ABS ESD material, which basically resists the electrostatic discharge. Then we have flexible material, which is TPU. Apart from that, if you want to have an assembly file, which we have PCABS, that is a composite material that we have. The plus point for this machine is, if you talk about 3D printing, whenever, wherever, we need supports to get the part printed. So in this machine, if you are printing something, the supports which you are using, those are water soluble. So you have to just dip the part into the water concentration for 1.5 hours, and after that, all you get is your part without any supports. So why leaders use additive for tooling jigs and fixtures? That because it's a cost-effective, time-saving, accelerated production timelines, and rapid replacement. So currently, what are the problems that everyone is having? Most of the traditional ways, which include CNC, these are very slow. So we have a case study in which we replaced a part which was earlier doing CNC, which was taking around 2 to 3 months. But after using it into additive manufacturing, we fulfilled that need into 2 to 3 days. So that is the plus point for additive manufacturing, which is into polymers. So if you talk about the traditional way, metal tool that is having a long range of layup that needs to be done. While into 3D printing, you have to do just pre-processing, print the part, finish it up, and you can use it anywhere, wherever you want. So here's the basically differentiation. In the left side, you can see that is the normal traditional part that you are having, which is actually costing around $40,000 to $60,000, and the lead time is around 2 to 3 months. Then in the right side, which we are having the part completely printed into F370 CR and bonded up together with special glues. So that was costing around $2,500, and the build time was around 40 hours. So this is around 90% of reduction into cost time. That is a plus point for FDM technology. So the materials that I talk about, those are industrial materials. So you can use it anywhere. If you are talking about jigs or tooling, so you can use that into steel industry. So one plus point for F370 CR is you can use carbon fiber material as well. So if you can see the brake press, tool and die, end of arm tools or soft jaws. So CF material, carbon fiber material is the mainly available for this kind of applications. So this is one of the use cases for work holding fixture of a CNC. So the if you can see into the right side, this is the part which got printed. The black part, that was nylon CF10. The white part that you are seeing, that is the support material. So we have to dip the part into water concentration for 1.5 hours, and all you get is the complete part, which basically holds this kind of working CNC part. So there is another application for jigs and fixtures. If you can see here itself, it has an internal cavity which was not available, which can't be printed into some other 3D printers, whether it is FDM or SLS, any of the technology. But into Stratasys, the cavity can be reproduced using soluble support material. So that's where this technology gets stand up. So if I talk about where jigs and fixtures are used, it can be used into assembly, quality control, packaging and logistics, health and safety, and equipments. So I'll not take much of your time. So yeah, the soluble support, which I already talked about. So this is one of the application. Then the plus point for using Stratasys machine is having a high heated build chamber. So what happens is, if you are talking about polymers, there are very restrictions. So if you are using 3D printers, you have already faced this kind of issue. So into Stratasys, we are having a heated chamber of around 150 degrees Celsius, through which your part accuracy will be excellent. It will be somewhere around under 15 microns. So that is the plus point for using high heated build chamber. Plus, if you are having a large part, so we have different chambers of the material that is using around 3200 Ci of material. So you can use either a large part as well. So if I talk about typical use into steel plant, so custom jigs and fixtures, sensor mounts, guides, housing, pipe to alignment tools, and tooling parts. So this is one of the case study which we have done for steel plant. So this is the corroded valve handle which we printed into polymer with the high temperature, which is nylon CF10. The cost which was there, that was reduced with the 50%. The timeline was around 80% reduced. So there is another case study for motors or pump fans. So this was completely broken, as you can see over here. So we printed the part into Diran, and it got heat resistant of around 130 degree Celsius. So also the cost has reduced for around 40 to 90%. So this I think you have heard about Opel. So they are using this machine for past around 8 years to print jigs and tool fixtures in their daily use. So apart from that, this is the polymers stuff which I just talked about. Now the next thing is we have the SLM machine, which is into metal 3D printing. So SLM are basically from Germany. They have just partnered with the Nikon. So we have SLM 280, which is into dual laser. Then we have SLM 500, which is quad laser. And now, just in 2020, SLM has introduced a 12 laser machine to cut off the time, which is having a printed part into metal. So the size that you are getting into SLM, that is around 600 by 600 by 600. The working capital, that is having plus point for reducing your inventory and having a digital inventory. So whenever, wherever you want to have the part, you just get it print and you can use it later on whenever it is required. If I talk about numbers of machines, so already 900 plus machines have been installed globally with the high-end customers, including Rolls-Royce, NASA, Mahle, Bosch, Collins Aerospace, and much more. These are also Indian customers which we are having right now. So this is the complete portfolio for the SLM. So currently we have SLM 280, which is having 280 by 280 by 365. Then if you talk about number of lasers, it is increasing rapidly from single laser to around 12 lasers, which is 5 times faster as compared to the quad laser as well. So if I talk about the materials, we have aluminum, which different alloys such as aluminum Si10Mg, AlSi93 cube Cu3. We have copper, titanium, we have cobalt, and we have stainless steel as well, apart from Inconel and other materials. So basically, with the SLM, we have productivity, quality, versatility, and safety. So these are the mainly required points which we are having. Plus, the plus point for this SLM machine is you have open architecture. So wherever you want to have metal powder, you can print your part into that material using SLM technology. So that is the point. Now, if I talk about reverse engineering, just like Chandra sir was asking, so we have 3D scanners. Faro is one of the precise 3D scanner that we are having. So these are basically specifications. So how does it work? If you can see over here, it has two kind of proposition. One is using the laser, and another one is using the probe. So if you are having a too much accuracy of around 15 to 20 microns, then we have a CMM probe which can be used to detect the surface of the part. But if you are having a little speedy process, so you can use these lasers, the blue lasers. So the robotic arm that we are having for these 3D scanners, that starts from 1.5 meters and goes up to around 6 feet, 6 meters. So this is the whole process. So yeah, these are the specification. Just like I told you about the accuracy. For the 2 meters, we are having 23 microns, and if you talk about 4 meters or more than that, then we have 68 microns. So yeah, this is all from my side. If you have any question, please put it up.
Thank you so much. I understand the time we had fixed for today's session was not, too much of a justice given the relevance and the amount of technicalities involved in this discussion. Nevertheless, it was a wonderful presentation, both for metal printer as well as polymer printer. A lot of potentials and the use cases is clearly visible that can be used. uh, in fact, it is being used in one of our own very plant, that is Rourkela steel plant. Many of our participants might be aware. If you have not had the experience, I am given an understanding that they have already recovered the cost
Boss,
of
can you mute yourself because
yeah,
it seems there is echo.
yes. Yes, you can mute yourself if you are not speaking. Yes, thank you so much. So what I'm given to understand that Rourkela Steel Plant has gone ahead and became leader in setting up one of the 3D printer in our organization, and they have recovered the cost by printing those small spares as well. So that is what I'm given an understanding, and now they are going into the benefit out of it, the additional benefit that can be accrued. So let me pause here for a few seconds and invite if we have any questions from any of the participants here. Okay. So I think we don't have too much of a questions, but I had some interesting backend chat with some of the participants who requested details of these printers. So we'll be sharing and we would be connecting you with them as well. Uh, so yes, so I can see that our head of academics, Mr. Atanu Mukherjee sir, has already joined, and also we have with us Sri Sanjay sir, who is head of HR L&D in SAIL. Yes, so let me first of all, request Atanu sir to kindly, we usually have him at the start of the session because we have such senior people joining and then we have experts. So, Atanu sir, may I request you to kindly extend a heartfelt gratitude and thanks to the entire SME team that we have here from Adroitech Information Systems. Tanu sir, please.
Yes, thank you.
I got one question.
Yes. Please. Just a second, sir. Let's take this question, please. Yes, Pramod
I
ji, please.
I saw repairing of teeth of gears using this 3D printing technology. How to repair teeth of bull gears, which are huge in size, and
So,
they have to be carried, or some arrangement has to be made. How it can be done?
so currently, sir, we are limited on the size. That's correct. We are attempting one from a plant which is Lalit has showed that has part has come to us. It's really very huge. It's 1 meter in length. We are making special fixture arrangements. But solution really lies, sir, that since we have the capability to manufacture customized metal 3D printers, so for the larger parts, we recommend the robotic arms, and we already have the design for it, and we are capable of repairing the larger gears as well. In fact, request has come to even repair an 8 meter dia gear of a steel plant while it is still working. Now, since resources are a crunch, currently our machine is capable of 500, 500, 300, which Lalit has shared. But we are capable, and of course, we are working with a couple of organizations, including Army, Defense, and Space, to grant us some money. And we are also open for taking CSR money because we are inside Atal Incubation Center and we are in a startup. And we are talking to a couple of people at CSR. So for your specific purpose, we can build and redesign and work out a machine for you, which can really take the larger parts as well as you have just described. So technology is not the limitation. Currently, the size is the limitation, and that limitation comes from the resources, because the funds which are there to be deployed is what we are awaiting. So, of course, down the line, we will be so. We are capable of doing it, but our current machine size is limited, but we can still attempt anything which is up to 500 to 6 dia, sir.
Okay, thank you.
Thank you, sir.
Thank you so much, Pramod sir, for your kind presence as well as such a wonderful input. Just to let the house know that sir is currently heading the entire L&D at Rourkela Steel Plant and is very closely associated with lot of technical developments there. So once again, sir, congratulations to the entire RSP team for leading in 3D manufacturing in sales, sir. Uh, Let me invite if we have any more questions. Okay. Thank you, sir. Thank you, everyone. Let me now request Atanu, sir, to kindly extend the heartfelt gratitude to the
Yeah.
SAP team. Yes, sir, please.
Before that, I just would like to extend an invitation. Anybody from SAIL fraternity wants to visit us. We are live and working inside RRCAT campus, and metal 3D printing is at work. And we will be happy to really showcase to your team if anybody wants. So it's an open invitation to entire SAIL fraternity. Anybody wants, they are welcome to visit our facility where we are carrying out all these works. So
Please
with
send
that,
your mail
yes.
to. Please send your mail. We'll send our people.
Sure, sir. We'll share it, sir. Sure, we will share it, sir.
So, sir, we have a metal facility in Indore and plastic and other facility we have in Noida. Our center excellence of the plastic 3D printing in Noida. So, there we install around more than 15 kinds of the technology, which 24 into 7 working for the industries association, and we are providing the spare part on demand part, prototypes, etc. to the different industry, automotive, aerospace, drone, UAV, healthcare, so all industry. So please also plan your visit, and we are kindly inviting our facility to Indore and Noida. So just intimate us when your official is
Definitely,
coming.
sir.
So
We'll
we'll
try
be
to
there.
formulate a team across our sale and we'll try to send a team on site to just to experience the technology.
Sure, sure,
Thank you
sir,
for
sure.
your kind
Thank you.
invitation, sir.
Thank you, sir.
Only
Thank
if
you.
people know what can be done with 3D printing, then only we will have our requirements.
Definitely,
Know
sir.
that
Definitely,
3D
sir.
printing has so much potential.
Sir, sir.
Definitely.
Okay.
Sir Atanu sir, may I request you, sir?
Yeah. Thank you. Thank you, Jagannath. And first of all, I like to extend heartfelt thanks to the total group of subject matter expert from Adroit Tech and Information Systems. Especially my special thanks to Dr. Manoj Jain sir, who is the CEO of this Adroit Tech Information System, along with Mr. Binod Kumar Pandey sir, who is also connected. And you people have provided a lot of insight, especially in this area of this 3D printing. That I mean, in fact, you have also created the 3D lab for Rourkela Steel Plant. What I mean, it has been endorsed by Sausab also from Rourkela as a head of training. So it's a great contribution you have done for Steel Authority of India Limited. So on behalf of the total team of Steel Authority of India Limited, we like to express heartfelt thanks to the total team of subject matter expert. Also, I like to thank Mr. Abhishek Mandal, Mr. Lalit Bajaj, and Mr. Vikas Mudgal. So they have also contributed. In fact, in today's knowledge bite session, lot of inputs you have provided, which has enlightened our the mentor who are at the younger people, and the mentee who are at the senior people who are connected. As you can see that our chief general managers of sale as well as the executive directors of sales are also connected in this reverse mentoring forum, and they need to be updated. They need to be updated with the latest emerging technology. So definitely, whatever input you have provided as a SME, that will definitely help our mentor to take the reverse mentoring process forward, and also it will enlighten our the mentee who are at very senior level people in the concept of this 3D printing. And Sausab has already endorsed that yes, it has got. And also, I like to thank special thanks to Dr. Jain sir. He has given a he has given an invitation to all the sales team. Definitely, sir, we will send our team to your premises to understand more details, and also they will have a hands-on experience in your lab. So that's all. And Sanjay Saab is also connected, who is heading the MTI, which is our corporate training center for sale. So we'll also hear from him also. Thanks a lot. Thanks to the total team of SME of Adroitech Information System. Thank you again. Over to Chandana.
Thank you so much, sir.
Thank you.
Uh, Yes. So we have with us Sri Sanjay Dhar sir, who is currently Chief General Manager HR L&D with the exercising power of EDHR L&D and heading the L&D initiatives across SAIL. He has been the backbone to lot of interventions that is going on in across our company, and one of the flagship intervention, that is the Anveshan we are conducting every month. And this was a special edition that we had on 3D manufacturing, and it was incidentally 19th episode that we have been doing. So without your support and guidance, sir, it would not have been possible, because we are trying to enlighten our senior leadership with technology, so that when it comes about decision making in adopting them, it would be very easy for them. So we are all waiting for your word of guidance, sir. Going ahead, requesting you to kindly share your thoughts, sir. Sanjay sir, please.
Thank you, Chandranath. I mean, I am more of a beneficiary of all the good work that you guys have done. I'd like to thank our esteemed panel of faculty who have shared their insights with us. I'd like to thank, in fact, the institution, RRCAT. I've been to that institution a long time back, 30 years back. It used to be called CAT only at that point of time, Center for Advanced Technology. And I know that they do cutting edge work. They really do state of the art cutting edge work, which a lot of other people beyond their academic circles are not even aware of. So to share your insights with us has been so kind of you, so gracious of you, and to offer a visit to our people to really see what is happening is again something that I'm grateful to you for, and I'm sure we'll take it up on with our plans to send a team out there, and for sustaining this interest in the state of the art technologies, and many times reminding us about how all these technologies are actually relevant to us it has been very important to keep them apprised about developments and also connect it back to what is happening in our own plants. So again, good work, Chandranath, for getting this process going, and all the participants who enthusiastically always participate in this workshop. So wish you all the best and thank you very much. And we look forward to actually doing something more interesting in the area of 3D printing, because that is the way forward for us. Thank you.
Thank you so much, sir. Thank you, everyone, once again. And with that, we are closing today's session. We will again bring you another exciting topic next month on first Saturday. That is actually going to be on, I believe, 6th of September. So I'm just announcing so that you can block your date. Thank you so much.
Sure,
See you
sure.
again.
Thank you.
Happy.
Thank you,
Thank you
sir.
so much.
Thank you. Bye-bye.
Thank you.
Thank you,
Thank
sir.
you.
Thank you.